Good morning to you all. So last day we have discussed about how we can create a binary search tree if a set of numbers is given, and then we have seen that there are three types of traversal and how this traversal actually happen. You can have a nonlinear search, I mean traversing in a binary search tree. And today we will start with a recreation of the binary search tree, and then if possible we will go for the uh, algorithm for traversal. Okay, so let's start the class for today. So basically we will do uh, I mean what my goal is to recreate a binary search tree from its traversal order. So before we proceed, one thing you have to understand that which particular orders is required to do this. So we have three different traversal order we have seen, such as pre-order, post-order and in-order. And you see, if you check this in-order, I mean if we have this tree over here in the left hand side, and corresponding traversal order is this for the same tree. And if you, for example, in this tree, one thing is very clear, that is root. Root is 10. So if you check the position of 10 in different type of traversal, what we can see? We can see that in case of pre-order, this root is present in the at the beginning. In case of post-order, it is totally different. Root is present at the end. And in case of in-order, root is present somewhere in between all the numbers. Now see, that means if I ask you that which are the traversal orders needed for recreating the binary search tree, you have to understand two things. First thing is that what is the root of the binary search tree, and then you have to understand, if you understand the root, then you have to understand what are the numbers should be present in the left of the root and what are the numbers, or I mean nodes will be present in the, I mean right of the root. That means left subtree and right subtree you have to understand. Now obviously left subtree also has a root. If you consider only the left subtree or only the right subtree, that also has a root, and on the basis of that root we have one of the left subtree of that left subtree and right subtree of another left subtree. In this way actually we can reach up to the leaf node, that's for sure. Now question is that if you compare these three different order, what is the root, you see it's not possible to understand by the in order, because if you don't have the tree in the left hand side, for just assume that you have only the in order is given, in that case only checking the in order you can never say that 10 is the root, even 12 can be root also. If I consider 12 is the root, the entire structure of the tree will change. But there will be a BST. So in-order cannot provide information of about the root of the tree. That is possible to be provided by the pre-order or post-order. Because pre-order contain first one is the root, and in case of post-order last one is the root. Whatever the number of other left subtree, right subtree numbers as given doesn't matter. Always the first character or the first number of the pre-order traversal is the root of the tree, and last character or number of the post-order traversal is the root of the tree. That means I need this pre-order or post-order to realize what is the root. But after that, what to do? What are the numbers present in left of the 10 and what are the numbers present in the right of 10? That is not possible to understand from this pre or post. To do this, you have to go through this in order, because in order says that left of this 10 should be somehow 1, 3, 5, 6 in some order, and right of the 10 should be 12, 14, 15, 18, 20 will be in some order. So that means only one traversal is not sufficient. I need either pre plus in order, or I need post order plus in order. One of these two combination. So let's do one thing. Let's start understanding. Let's try to, recreate the BST using this approach. Obviously, if this approach we can understand, then this is also possible because the approach is same. So let's write the in order traversal list first. Pre-order list first. So 10, 3, 1, 5, 6. So pre-order is 10, 3, 1, 5, 6, 15, 12, 14, 20, 18. 15, 12, 14, 20, 18. In the same way, we have to write the post order, in order also. In order is okay, so it will be basically small to the highest. So 1, 3, 5, 6, 10, 12, 14, 15. 1, 3, 5, 6, 10, 12, 14, 15. I think it will be 18, then 20. Yes, 18, then 20. Fine. Now let's take another pen over here. So here I know that from this pre-order traversal, the first one is the root of the tree. So let's write the name, just mark it place of 10, this one. Now see, since this is root, so I can easily draw the root first. Fine. And then we will start checking from here and we will go in this direction, always remember. So we will first pick up 3. Now what is the strategy? Strategy is that just check the position of the other values with respect to the current root. Currently the root is only 10. So this is, if you pick up 3, what is the position of 3 with respect to the current root? That is 10. It is left. So 3 should be in the left of 10. That's for sure. Now left of 10 is free. Right now it's blank. Since it is blank, that's why you can simply connect 3 over here. Then let's pick up this 1, and you see the position of 1 with respect to 10. Okay, just a minute, let's mark this 3 again. Now see the position of 1 with respect to 10 first. We will start from here always. Okay. So 1 is left of 10. So 1 should be the left hand side of 10. That's for sure. Now left of 10 is already filled up. So let's come to 3 first. Then we have to, that means now we have to check what is the position of 1 with respect to 3. Because 3 is the more left. 3 is in the more left. Right. So with respect to 3, it is also left. So 1 is also left. So that means left of 3 is blank here. So since left of 3 is blank, you can easily connect 1 here. And then 5. Similar way, 5 is left of 10. Left of 10 is blank. I mean free. Sorry, already filled up. Let's come to 3. So with respect to 3, 5 is in the right hand side of 3. So that means I can connect 5 over here. Now you see we have got 6, and we can see that 6 is less than 10, greater than 3, I mean in the right of 3, and right of 3 contain 5, so it's again right of 5, so that means 6 will be somewhere here. Now 15. 15 is what? Right of 10. So this side is completed. Fine. So 15 is right of 10. Right. So and right of 10 is right now free. It's blank. It's not connected with any other node. So I can directly connect 15 over here. Then 12. So let's mark 15 right now. 12. So 12 is also greater than 10. Fine. But right side of 10 is, actually not free. So let's come to 15. Now see position of 12 with respect to 15. It's left. Right. So I have to put this 12 in the left of 15. Left of 15 is blank. So you can easily put 12 over here. Then 40. Yes. So 12, then 14. 14 is what? 14 is greater than 12, right? 14 is greater than 10, so it come here. 14 is less than 15, it will come here. 14 is greater than 12, current last entry. So that's why 14 will be somewhere in this side. Similarly 20. Now 20. 20 is greater than 10 and greater than 15, and greater than 15 means actually right side of 15. 20 is present in the inward list right side of 15. So right side of 15 is not occupied, so you can directly connect 20 over here. And obviously you can find 18 easily, which is left of 20. Something like this. So using this set of traversal, you can recreate the BST, and if you compare with the previous one, what was there actually, you see the same structure we have found. So that means one way to realize whether you have correctly uh, written the traversal orders or not is that try to recreate the tree from the traversal that you have got. If you find the same tree is found, that means your traversal order was correct. If you find some different tree with respect to a single node even, that mean that you have mistake either at the time of writing the traversal or maybe at the time of converting from traversal to the binary search tree. any one place. So these things are very useful if you want to have a practice in your home for writing various traversals. Now question is that uh, okay, fine. So we have seen that how we can recreate the BST from a traversal.